Okay, well, thank you everyone for coming. Welcome to the November Calgary Elixir meetup, the last one of the year. When I was in an elevator going to get someone like 30 minutes ago, I realized that it might have made sense to like do a recap of 2025 because I think this is like the first full year that we've been doing it this way. But I didn't prepare anything, so I think it would have been cool to like recognize like the new people that have joined, or like the speakers that we've had, or like the people that have like come and been like repeat members, or see like how our numbers have grown, because we've like definitely breached 20 for a couple of the meetups this year, but I don't have any of those numbers, so I think we can just like celebrate 2025 as like the first full year, and this is awesome. But like there's a lot of repeat customers. I think everyone here has been to at least one, so it's like pretty wild to see that like there's enough people here to find this like valuable enough to come to this little community we're building. So it's really cool to see. So thank you guys for coming. So yeah, before we start, we'll just do like all the shout outs to the sponsors. So my company Hive, they've provided the pizza and the beer for tonight. So big thanks to them. They're also hiring right now. So Kevin and RBC, they give us this wonderful space, which is great. And another awesome thing that we've got in 2025 is our very own videographer. So Grigori comes with a camera. It's great. And he records our talks, and then we put them up on YouTube. We've got a YouTube channel.
Oh, you've just gone through the room.
Yeah, we're like a legitimate operation now, which is kind of sweet. So yeah, thank you for like growing this with us, guys. That's great. So yeah, before we get too sappy and I'll start crying, why don't we just get into GenServers Part 2. We're going to be talking about supervision and advanced patterns, and then we are going to see a demo app at the very end, and you guys can all interact with it. So I kind of took a page out of Kevin's book for this, and I just got Claude to write the presentation and the app for me. I've gone through it once or twice, so we'll see how it goes. But it was kind of refreshing to just be like, this was part 1. These are the things that we didn't cover. Now just give me part 2, and it gave me part 2, which is sweet. And some of the writing like maybe sounds like me, but maybe it doesn't. So we'll go through it and we'll see. But yeah, a little recap. You know, last time, if you remember, we talked about processes, how those are like the atomic piece of work, so to speak, in Elixir. We talked about how to make them like long-lived and how we can get them to store state with recursion. And then we talked about GenServers, like a very basic introduction to them, and they kind of give us an abstraction over all this, so we don't have to like worry about the actual like state keeping mechanisms. As developers, we can just like worry about handling the state and passing messages around. So today we're going to talk about supervision. So this is keeping our GenServers alive or restarting them when something goes wrong. We'll talk about name registration, so how it's easier to find them and communicate with them. We're going to talk about a couple other callbacks, handle info, handle continue. So these are useful when communicating with our GenServers, and then we will see a little app that you guys can interact with, and you can see all the concepts in action. So what happens when a GenServer terminates? I mean, it's probably the exact same thing when a task terminates, like we saw last time. It dies, and then you can't do anything again. So if we try it here, we've got a little code block with a GenServer called terminating server. And we're going to expect to kill it after we compile it and run it. So we'll start it, process alive. If we call the terminate function, what do you think will happen when we ask it if it's alive? True or false? False. It's not alive. It's dead. So this is not great if we start thinking about Elixir in like a production or an application setting. If we've got a GenServer, a process that's meant to hold state or meant to do something for a while, if it's dying, then we can't really use it anymore. We don't have access to it, and this might bring down our whole application. So what do? We use something called a supervisor, and these are special processes. I mean, they're a process like anything else in Elixir, but their job is to monitor other processes and restart them when they die. And according to Hex docs, a supervisor is just a process which supervises other processes, which we refer to as child processes. So supervisors supervise children. They're used to build a hierarchical process structure called a supervision tree, and supervision trees provide us with a fault-tolerant system, and they encapsulate how our applications start and shut down. So we can start a supervisor for a terminating server using the supervisor.startLink function. and we can see if the terminating server is alive. Yes. And now if we kill it and we check if it's alive after a little bit of time, we see that it's alive. So the supervisor realized that one of its children died and it revived it. I mean, really, it started another process with the same parameters, but we now have this process back again. If it died, the supervisor restarted it. So there's several supervision strategies that we can follow.
Can I interrupt, or like, I have a question?
Sure, yeah.
So when supervisor restarted, what happens to the peak?
You are usually assigned a new one. Sometimes you might get the same one.
So like you can rely on having like a feed and to send a message to a process. So like if you're not a supervisor and you need to interact with the process, you get a peak potential. How do you like recover from this?
We will talk about that when we get to name registration. So you can register your children with names, and then you can refer to them with a name, like an atomic.
The process can send message to a name instead of PID.
Exactly, yeah. So it's like an alias for a PID, but you don't really need to know the PID because the registry handles that mapping between the PID and the name. So there's a couple supervision strategies that we can use, and this is kind of, this comes into play when a supervisor has many children. So we've got 1 for 1. So if one child crashes, only that child is restarted. We've got 1 for all. So if one child crashes, we restart all of them. And then we've got rest for 1. So if a child crashes, the child and all the children started after it, they're terminated and restarted. So this is like if you start them in order, if one of them dies, everything after that you're going to restart as well. So let's see how this works. We've got this new GenServer called counter GenServer. All it does is it stores a state of counts. You know, every time you hit it, it just increases the number by 1. So we'll compile this, and then we will start a supervisor with 3 of these children, and we're going to name them counter 1, 2, and 3. And this is how we can communicate to them. This is the name that we've given them, counter 1, 2, and 3. And we can ask them for the counts, and right now, none of them have anything. We haven't asked them to count anything. So if we tell counter 1 to count to 3, and then we ask all the counters for their state again, we can see that counter 1 has got 3, counter 2, and counter 3 have 0. And now what we're going to do is we are going to kill counter 3. And if we've got a supervision strategy, what do we expect is going to happen when we ask everyone for their state again? Everyone starts with a state of 0 because we've restarted everything. And counter 1, after counter 3 died, we just restarted everything. Now we've got something called a dynamic supervisor, and this comes into play when you don't know how many children you need at startup. So a supervisor, you need to tell it how many children it's going to manage at application start. But if you've got a system where you've got sort of children or processes coming in and out of the supervision tree, and you don't know how many you're going to have, or you need to be able to add and remove them, you use a dynamic supervisor. And for a dynamic supervisor, you can do the same thing. You can assign children, but you don't have to do this at application start. You can do this at runtime. So for our dynamic supervisor, let's give it some children. We'll give it 2 of these counter apps, 2 of these counter GenServers. We will count them. And now what we're going to do is we are going to remove one from the supervision tree. So we're going to take one of these children from the dynamic supervisor and see what happens. So if we remove counter 2 by terminating it, we can see that counter 1, if we ask it for its state, still has a state of 3. So if you remove a child from a dynamic supervisor gracefully, you're not going to bring everything else down. But if you were to do this to a regular supervisor, you would have to go through the restart strategy and start all the children back up, depending on the strategy. So supervision tree, we've kind of like mentioned this a couple times. This is really just a way to visualize like how processes are managed in an Elixir application. So it's really just like a tree structure. Like you've got a supervisor, it manages children. Supervisors can manage supervisors, and they can manage supervisors. So it can be supervisors all the way down if you want. But this is a really good way to isolate different parts of your application and keep, a failure in one end from impacting processes in the other. And that brings us on to name registration. So as Grigori asked, if you kill something and you restart the process, can you communicate to it with the same PID? Maybe, maybe not. That's kind of up to chance. But if you register things with names, you don't actually need to know the PID. You can reference it by the name that you've given it. So here we've got a gen server, and we're going to give it a name. Actually, we're not going to give it a name. This guy, we're going to give him a name. We're going to call him my counter. And you can get things from it by referencing my counter as the address that you're sending your calls to. So that's kind of nice. Next thing we'll talk about are other callbacks. Kind of like we mentioned, we're going to talk about handle continue and handle info. So handle continue, this is a callback that we call right after init returns, but it doesn't block the start link call. And this is important because if you've got an initialization process that takes a long time, these things happen synchronously, and so you could be delaying your application start if you've got something that runs for a long time. But if you pass that long setup to handle continue, you're not going to block the init call, and you can kind of do that asynchronously, which is kind of nice. So here we've got another gen server. We're going to call it slow start server because it's going to be slow to start. So we've got this init call. We've got handle continue, and that's all it's going to do is just sleep for 2 seconds. And when we start that, we can see that we can still interact with the process and the application while this is going. So we're not going to block our application start for 2 seconds. We can just keep going while this thing starts, which is kind of nice. And then the other one that we're going to talk about is handle info. So handle info handles messages that are sent to our gen server with send instead of call and cast. And those are the callbacks that we talked about last time. So this is useful for messages, system style messages like exit when you're trying to kill something, messages from like timers. If you want to like do something on a recurring schedule, you can do a handle info. And this is really just like meant to like catch things that aren't really in the typical like handle call or handle cast sort of like wheelhouse. So if we've got this ticker server, what we can do is we can send an interval every 1 second. We're going to call tick. And here we're going to handle this info. We're going to handle this tick message every second. And you can see that after we compile this and run it, we're going to tick every second. So this is just a way to handle like an info style message without using the other callbacks. So if we put this all together into our auction app, which we're going to see in a second, we can use GenServers to manage state. So in the auction app, we're going to use it to handle our auction state. It's like how much time is left in the auction, who's bidding, what the winning bid is. We're not going to use a dynamic supervisor in here. Claude just put it in because I told it to summarize what we've talked about. We are going to use the registry for our name registration. We're going to register our gen server for the actual auction with a name. We'll use handle info for countdown timers. We're not going to use handle continue because we're not getting anything from the database here, but you could use handle continue for something like that. And we've got like a very basic supervision tree in the application to handle it. So we can pop over to the app and see it in action. And if you guys would like to participate, I've got a QR code here that you can scan. It'll take you to a very basic login page where you can put in a little nickname and then a password. And the password is just Calgary Nov 2025, like this. Is that big enough for people to see, or do I need to increase the size? I think I should increase the size. Oops. Are people in? Can they see? Okay, cool. I will start. An auction. I'm going to join in as well. I'm going to join in on the fun. We got 15 seconds left. I'm going to put in a huge bid. So I have the best bid. Okay, someone has exceeded me. Other Kevin has won the auction. So this is like a super, super basic vibe coded like implementation. So the actual like auction itself is managed by a GenServer. All it does is it handles messages from these live view processes of who's sending the bid and how big it is, how much time is left, and there's a handle info every second to send a message back to the live view to tell you how much time is left. And whenever someone places a bid and it's the biggest one, you get a message back. So super simple. We can look at the code if you guys want, but it's really like a couple dozen lines, super easy. We've got the start link here. We've named our GenServer with the module name. So anything that wants to communicate with it, all it needs to do is call it by auctiondemo.auctionserver, which is nice. So if it ever crashes and restarts again, we don't need to know the PID of the new process. We can just call it with the name of the module. We've got the start auction callback, reset auction callback, and receive callback. This is really the only things that it does is it receives bids, starts an auction, and restarts auctions. And then here are our callbacks for this. So init just sets an initial state, nothing crazy. We store that. Handle call for start auction. This is what I did when I started it, was just set a new auction with 30 seconds remaining. And then we broadcast the state change to all of the live view processes using PubSub. And I think Kevin L is going to be talking about PubSub, so you guys can see how that works in a little more detail. And then, starts a ticking timer every second. We send ourselves a message to tick. We got this get state, which just gets the state from it. We've got a reset auction callback, which we can use to reset the auction. I put this here just in case some web crawler ended up kicking off an auction between me launching this and this talk starting. We've got this receive bid callback. So if the bid is active and if the bid exceeds the current best bid, we update the state and we broadcast the state change, again, on that PubSub topic. And then here we've got this handle info for tick, right? If we've got no time remaining, we just complete the auction and we broadcast back to all the live views that we're done. We're not accepting any more bids. And then here's the other handle info for ticks. If we've got still time remaining, we just subtract one from the state and we start over again, send ourselves another tick to handle this in a second. And that's it. That's super simple, super basic, but this is how you can use a GenServer to manage an auction. And you can just tell Claude to build this for you and it'll one-shot it, which is super nice. And I think that's really it. Some resources. We've got docs if you guys want. These are links, so you obviously can't click them. I can click them, but you can't. And this is all in a repo, so if you guys want access to this, I can put it in the Discord later. But yeah, that's GenServers. Seeing them in action, super, super easy stuff. Thank you. Kevin, questions?
These aren't questions, these are just annoying comments that I have.
Okay.
So, fun fact, supervisors are just GenServers under the hood. If you go look, they're just a GenServer. So effectively the state of that GenServer is
the children that it manages.
Yeah, the processes that they're supervising. Just another one, if you go back to where you're doing the name of the name process.
In here or in the?
Yeah. You're calling it an atom.
Yeah.
Yeah. So just to point out to people is oftentimes you'll see name, but it's like some capital letter thing, and it looks effectively like a module name, and a module name is just an atom. So you may see that syntax that is basically referring to the same module.
Yeah.
Or you can see like a different module name. So that's not just so you're not confused. The module name is just an atom. It just doesn't have exactly the same syntax. So if you do see that in the wild, understand this is not some weird thing. This is expected. And if you're telling it to use the module name as the name of your process, there's nothing magical about that. It's just using that as a label. So
Yeah.
It's not necessarily directly associating that module with it. It's just using it as like a label to tell what the thing is. So there's no magic association going on there.
Correct. And we all know what atoms are, right? Nods. It's just like a variable that is itself, basically.
But it's synchronized across nodes. If you have
That
a
depends if you have a registry.
So it's not like it's default behavior, but like idea of using.
If we're talking about atoms as like the name of a process, you have to register them if you have multiple nodes running, because then you can have like how do the two nodes know to communicate to each other? So there's a thing called a registry, which you can use, and this will synchronize the names of your processes across multiple nodes.
Atoms themselves. So atom is just an integer in Vim, and from what I read, integer ID of an atom will be same across cluster.
So if I was to, in one cluster, like use an atom as a variable and another one as a variable, it's going to be...
Have, like, different like underlying integer.
I actually don't know. I'm not sure.
No?
Because you can exhaust the atoms. If you use string to atom, you can exhaust a number. So there's like infinite possibilities of atoms, but there's only a finite number of atoms that you can assign. So that's per node. You have a maximum number.
Don't use string to atom willy-nilly, or
Yeah.
you will use up all the atom space and
Yes.
crush the whole thing.
Yes, but just, yeah, you can make as many atoms, like there's no finite amount of atoms that you could make, but there's a finite amount that you can assign, and then it will crash the beam.
Oh, but like realistically, can you exceed like as a like this
There is
integer space?
Yes, you can exceed the number that is maximally assigned. So I think, I'm not 100% sure, but I think that they're assigned in the like integer of like 0 is the first atom that you define, 1 is the next atom that you define. Yeah. So it's not like some sort of hashing thing that's like always landing on the same integer.
Well, as I understand, there's a protocols that like synchronize. So like I start reading like what the hell is atom, because it's like not every language have like an atom or something like similar to it. So I start reading like why is it there, and as I understand that this is actually exists for synchronization across nodes in a cluster.
Yeah, I imagine, I've never had any problem using atoms across the node, so I can't imagine that there'd be a, like, there's gotta be some
Yeah, because
synchronization.
you can send a message across a node, and the message will be identified by an atom, and it will like work on another node.
But not
So-
every node is known. So
So if you're going to send a message, there like should be like way to figure out that this is the same atom on this node as on the other node.
yeah.
So like it was a while when I read it, but as I understand, this is like under the hood how it allows all the like different nodes to live in the same space and exchange messages without getting confused. Like that you have a key here and a key in another node, and they should point to like should be identified that it's the same thing, it's the same message.
Yeah.
So there should be some way of synchronizing them.
There is a distributed registry that you can do, but I don't know. Anyway.
Yeah, so I think it like depends on your usage of an atom. And this is kind of like a non-answer, but if you're using atoms to like pattern match in like, let's say the function head of a function that like pattern matches on like the shape of a message, I don't think it necessarily matters, because you're going to fall into that function regardless of what the atom maps to on either node. But if you're using atoms to name your processes and you want them to be uniquely named, you need to register these names in the registry so that multiple nodes can recognize that this singular atom maps to this PID, if that makes sense. So it's this data structure where it's like a variable that is itself, but the way that you use it also defines if it's unique or not across nodes. I hope that makes sense. And I hope I'm not like kind of making up answers, but
because the typical case you have like one node that start a server, so start a GenServer, and use it like for example like module atom ID as an identifier for GenServer, and then you start something else that like aware of like it's a separate node, but it knows about this module and how to communicate with it, and if it needs a bit of a process, it should be able to use the same atom, and there should be some way of synchronizing them. Otherwise, you won't be able like to like.
yeah, so that's what the name registry is for. So
Registry for processes or for atoms.
so you register the name. The name is that.
Why are you coding it like that?
Why what?
Yeah, why are you going to go across PIDs? Why wouldn't you just have one PID to look after the task? Why does this matter?
Because it can be restarted if you like.
So,
The peak is gone.
so the question is, if you've got two nodes, right? If you've got two nodes, and you've got a process that is meant to handle a message,
Yeah.
how do you make sure, for example, that you don't have two of the same process running across nodes and they both handle the same message? Because that's silly.
And probably unintended.
And yes, very unintended. You would use like a name registry to make sure that across all of the nodes, it is known that this one atom maps to this one PID that maps to this one process.
I believe if you want to be like sort of unique in a generative way, you can use a string for the name if you really wanted to.
Yeah, you don't have to use atoms. You can use whatever you want.
Like an
Only
integer
to
or
use
something
the
like
byte
that.
tuple.
So
But would it work with Atom? So like, do you need to use string or like Atom actually like being provided you some sense, let's say like key?
the atom is marginally faster.
No, I mean I'm not about speed. About like, is it safer with a string or like is it, you can just go with Atom and use this module name?
We just use AI to look up what's happening.
Yeah, why are we discussing this?
We're professionals.
We're gonna get replaced by this anyway.
Yeah,
they're not
It's like
synchronized.
the strings preferred. Like your database is gonna correspond to an integer, not to a string. Your database is gonna have numbers inside of it, not strings. You're not using base
Doing our
26.
presentations in AI, and then we're trying to answer the questions with our trade.
Yeah.
What's the answer?
Well, I know what ChatGPT says. I don't know if that's the answer.
ChatGPT makes sense of this?
So between you and ChatGPT, I'm sure you could take.
Well, ChatGPT says atoms are globally unique constants,
Global variable.
and Erlang's distributed runtime supports global atom tables that are consistent across connected nodes, which would make
Yes,
sense.
as long as they're
Which would be
connected.
why I've
Yes.
never destroyed a server that way.
Yeah.
Mine says the
Opposite? See, well, that's why I said.
Also
ChatGPT.
ChatGPT.
So
I guess we'll never know. So we'll put this up on YouTube, and some like hyper nerd in Sweden is gonna be like, actually.
Reply down below.
Yeah.
Reply down below.
Something else also very exciting the first time you hit it. When you start your processes, your supervisors, you can say, if this thing crashes like 5 times in a minute, kill me. Like kill the supervisor, and it'll ripple up and kill the whole app, or at least notify its supervisor that it has died.
Why aren't you
Because
doing a try catch?
it
You're
is
expecting it to crash.
well, it's Elixir, let it crash.
Yeah.
Things crash all the time. You want to let them crash, but if it crashes like 5 times in rapid succession, there's something more going on than just it crashed. So you want to say this is a real problem and signal that up. And typically what happens is that you just drop the whole app at that point. And, if you don't know this is what's happening, it's a very exciting time because you're like, why did the whole app crash? Like, and eventually.
That was a very exciting time in my life.
So there's some default behavior, like say like 5 times a minute is the limit. So you have to do
Yeah,
like
so what you're saying is, yeah, if this thing is
How many
crashing,
times in a
especially if you're hitting like an external resource,
Mhm.
and if you can't hit that external resource like the database, the app shouldn't be running if it can't hit the database because you can't store anything. You can say, okay, well if that happens, you're going to crash repeatedly trying to hit the database. If you crash that much, bring down the whole application so we don't keep trying when there's no database available. And that'll all happen automatically, so you don't have to worry about it until you get a call in the